Hi, good afternoon, ladies. Just let me know that you can hear. We're gonna jump straight into it. Once you guys confirm that you can hear. All right, awesome. Okay, so we're going back over everything. What we're gonna be doing today is that we're gonna be just recapping everything we've done. We're gonna be strengthening. Let me make sure our session is being recorded because I think it would be a good session to share with other persons. Okay, so we're gonna just recap on the basic concepts and go up until everything we've done in our previous classes. So just let me know if you guys are ready. Type ready, and we're gonna begin. Okay, that's one person. I know I want to be able to move a little faster than usual, so I'm gonna need you guys to respond a little faster, okay? So we can get through this quickly. All right, so I'm just gonna go through the basics of algebra. As we know, algebra is the part in maths that uses both letters and numbers, right? So there's some things we need to remember. Letters, any letter is called a variable. Any number that stands on its own is called a constant. It's called a constant. And most cases, we have numbers that come right before variables. So for example, if I had 4p, what you always need to remember is 4p simply means 4 times p. Okay? And the 4 in this case, let me use a different color. The 4 in this case is called the coefficient. Obviously, the p would always be called the variable. So those are the basic information or the basic terminologies that you need to remember. Variable for the letters, constant for the numbers. And whenever you see 4p, you just need to remember 4p means 4 times p. Similarly, if you see a term AB, that simply means A times B, because there's a rule that suggests whenever you multiply two variables, you just join those variables together in alphabetical order. All right, so here we have some examples. We have 8AB, knowing that A is called a coefficient. Let me just zoom in a little bit. We're just going to go through this quickly. All right, so as I was saying, so here we have a terminology, algebraic term, 8AB. And we know AB is actually called the variable. In this example, you realize this is a double letter variable. So sometimes you can have a single letter variable or double letter variable or triple letter variable. All of them are different. Now, I just want to highlight something. We know that 2 square means 2 times 2. So similarly, if we have p square, we know it just means p times p. All right, same concept that we learned before, just that it is applied to the letter or variable terms. Now, the coefficient could be a positive whole number, a negative whole number, a positive fraction, or a negative fraction. Okay, so just like how we have here 3p, 3 is the coefficient. It just says that we have 3 p's. Negative 2m, negative 2 is the coefficient in this example. Everybody with me so far? Let me know. Let me know. Yes or no? Because remember, we're just going through this quickly. All right, so we have some algebraic terms, and this is very important because when we go to learning or revising addition, multiplication, and subtraction, these are the elements you have to remember. Whenever you get an algebraic term, you have to pay attention to the sign. Is it a positive term, negative term? You have to pay attention to the coefficient. So the numbers that come in front of the variable. You need to pay attention to the variable. Is it a single digit variable or a double digit variable? And then most times the variables have a power. And we should always remember, power is the same thing as the index or indices or exponents. These three terms mean the same thing. Everybody with me? So for example, in 2a, we know that this is a positive term. We know that the coefficient is 2. We know that the variable is a. And one of the rules you need to learn, let me go over here. Let me just zoom out. One of the things that you need to learn is that whenever you are giving a variable, let's say for example, a has a power of 1. It's just that we don't say it. And a also has a coefficient of 1. If I say you have an apple, you should know an apple means 1 apple, right? So this concept is something sometimes most people forget. So I always want you to remember, any variable that stands alone, even though it doesn't seem to have a power, the power is really understood to be 1. Even though it does not have a given coefficient, the coefficient is always 1. Everybody with me? Please let me know. Let me know got it, that you got it. Let me know that you got it. Because again, it's very important that we on the same page about all of this, because we're going from scratch and it's going to be a bit challenging. All right. So as we see here, negative 3b, it's a negative sign. The coefficient is negative 3. The variable is b. The power of b is 1. In this example, the m square is positive. The coefficient is 1, even though it's not there. The variable is m square and the power is 2. In this last example, you realize this is a double letter variable, so we must pay attention to that. Here we realize the coefficient is 2. The variables is p and q, and for each, the power is 1, because each individual variable stands on its own. All right, so let me just go and see if there's anything else we need to touch on. All right, so we have here the same rule, just like how I told you. If you have a times b, the answer is just joining those two things together, ab. So if you have a times b times c, it simply just means a, b, c in alphabetical order. Okay, so let's keep it moving. See if there's anything else that I want us to touch here. I think that's about it. Looks like we cover everything. So we're keeping it moving. Now, this is important because it looks a little confusing. So let me just clear it out. This was a question that came in CXC this year, and a lot of persons were unable to answer because, to be honest, this is the basics, and that's why persons got caught. They were prepared to answer more complicated questions, but not more difficult questions. Now, in the beginning, we learned some terms. We learned that what sum means. What does sum mean? If I actually find a sum of two numbers, what it means to do. What does that mean? To add. If I actually find the difference, what does the difference mean to find? What do you do? Very good, Ashley. Thank you. So what is the difference? Somebody, anybody? If to subtract, somebody said subtract, thank you. So sum is to add, difference is to subtract, product. If I actually find the product of two numbers, to multiply. Product is to multiply. And the last one is quotient. Quotient is to divide. This is very important because if you don't know these, any worded problems can throw you off. And so here we have here. Sum is to add, difference is to subtract, product is to multiply, quotient is to divide. If you know you need to write that down, you need to make sure you have that written down. So here we need to translate these worded statements or expressions and express it as an algebraic expression. What do that mean? We need to understand the difference between an expression and an equation. If I give you 2 plus 3, 2 plus 3 is just a regular maths expression, but 2 plus 3 equals 5 is an equation. What makes it an equation? The equal sign. This is very important because most people get confused between an expression and an equation. Similarly, if I tell you A plus B, this is just an expression. It's not equal to anything. But if you have A plus B is equal to 4, this is where it becomes an equation because it's equal to an actual value or equal to a given amount. All right, everybody with me? Let me know, got it? We're gonna have to be saying that a lot because we're moving too fast and I need to make sure we're on the same page. So, all right. Of, somebody mentioned that, very good. Of, so just to repeat, expression is when you just have some terms with an operation, but no equal sign. Equations have an equal sign. So on the left-hand side, these would be expressions. On the right-hand side, these would be equations. So here we need to change these sentences to expressions. It says 7 times a number B plus a second number H. How do we represent 7 times a number? We don't know the number, so we have to use a letter to represent that. So this is something we need to be very, very confident about. If I ask you 7 times a number, 7 times, let's choose any letter. Let's choose M. So it says 7 times a number B. That's the first section. How do we represent 7 times a number B? You see, I go on and choose M. Who tell me to choose M? They already told me what the letter is. They asked for 7 times a number B. So I should write 7 times B. The second part, it says, you realize that it's separated by a comma. So you pay attention to that. Plus a second number H. So that means I need to do what? Add H. But you learned something before. 7 times any letter is something. What is 7 times B, guys? Type it in the chat quickly. What is 7 times B? You learn what you're supposed to do when you multiply a number and a letter. 7B. Very good. And then you put plus H. That's it. That's the answer. Let's look at the next one now. 3/4, the product of two numbers, M and W. No, you have to break this down. It says 3/4 of the product. Before you find 3/4, you must find what first then? You must find the product of two numbers. What is the product again? How do we find the product? What does the product mean? To do what? Remember, we're moving too quickly. When somebody says find the product, what are they asking you to do? Multiply. So they say find the product of two numbers, M and W. So that means we're finding what? M times W. But what is that equal to? We learned that whenever we multiply two variables, what is the answer? So what is M times W, guys? Let's go. MW. Thank you very much. Do everybody agree? Is that true? Is the answer MW? Talk to me, talk to me. Yes, because all we need to do is join those two letters. So we get MW, but that's not it. They ask us to find 3/4. So if I want to find 3/4 of, same thing is you multiply, you're going to find 3/4 of MW. That's it. Let's do number 5. 5 times the sum of X and Y. So let's get the first part. Everybody, how do I find 5 times the sum of X and Y? Before I multiply by 5, I must find what? The sum of X and Y. How do I write the sum of X and Y? What is the sum of X and Y? What is the expression? Take a try. Sum means 2. Okay, one person sent it. What about everybody else? Let's go. It's a small group of us. I need everybody to try as much as possible to answer the questions. Nobody else knows? Okay. 5 times the sum of X and Y. The sum of X and Y means to add X and Y. So it's just going to be X plus Y. And so 5 times that, we know we just put it in brackets because it's 5 times all of it. And we put 5 outside because we learned that this is using the distributive law. So everything inside is multiplied by 5. So everybody see the basic concept of writing the expression from the sentences. Let me know if you got it. Let me know if you understand the basic concept. So got it? Not got it? Let's go. Let's go. All of this is reinforcement. All of this is us making clarity on everything we would have done before. All right. We did like terms. And we need to understand what like terms mean. So here we have in our notes, if two or more algebraic terms have the same variables with the same power, they are called like terms. So for example, we have here 5a, 3a, and 4a are all like terms. B cannot show what you mean. So I can probably come back and ask you what you mean before, okay? So we're just moving along for now. So pin that question for me or send it to me via WhatsApp so that I can always answer it after. All right. So we're moving along. So here we have like terms. So 5a, 3a, 4 like terms because they have what? The same variable with the same power. 3b squared, 7b squared, 8b squared are all like terms because we have the variable with the same power. Remember, that's important. Even though we have variables with the same letter, b and b squared are two different variables. They have two different meanings. So we have here now 8ab cubed, 9ab cubed, 2ab cubed. All of them have the same variable, so they are all like terms. Similarly, in the last example, you would realize that we have a negative 2a, a 3a, and a quarter a. The coefficients don't matter. The only thing that matters is what the variables. All of them have the variable a, so all of them are like terms. Everybody with me? Let me know. Let me know. Yes or no? Got it? Don't got it? So that's one person. So T said she got it. Ash, Bika, do you got it? Okay, Bika said got it. What about you, Ash? You with me still? All right, so let's keep it moving. Now, addition and subtraction. This is the first operation you're going to learn because the truth is it's probably the most intricate because you have to pay attention to the rules. The rules is simple. When you're adding and subtracting algebraic terms, there's a specific rule you have to remember. We can only add and subtract like terms. You can only add and subtract like terms. So if they're not like terms, you can't do nothing with it. So we did some examples. Let me scroll out because I think we did some easier ones first. Yeah. So let's look at the first. We did some 7 questions. So let's look at these 7 questions. So here we were given 2a plus 3a. 2a plus 3a. We know we can add because first thing first, they're like terms. And this is how you should think about it when you're adding and subtracting algebraic terms. Think about it like apples. If you have 2 apples and you add 3 apples, how much apples do you have? You have 5 of them. Now look at example number 2. You have 2 apples plus a banana. Can I add those 2 terms? No, because A is different from B. That is why you write back the same thing. They just do this a lot in CXC. They will give you a question like this, and some people will leave it blank because they will think, oh, I can't add it. You still have to write it back because this is the answer. 2AB would be wrong because that could only happen when you're multiplying. Are we multiplying? No, we are adding. When you're adding, you only could add like terms. You can only add A's to A's. You could only add B's to B's. So I have a question for everybody. If I had 2AB plus 4AB, first question, can I add those 2 terms? Yes or no? 1 person responded, 2 persons responded. Can I add those 2 terms? Yes. Why? Look at the variable. This variable is AB. This variable is AB. So I can add an AB to an AB. So what would be my answer now, guys? Let's go. If you got 2 of them and you add 4 of them, how much you have? What's your answer? So one person responded to T. What's your answer? Excellent. So the answer is 6AB. What about this one? Suppose I gave you this. A square plus 2A plus A to the third power. What's my answer? Can I add these 3 terms? Yes or no? That's one person responding. Can I add these terms? T, what you think? You cannot add these terms. You know why? Even though the core variable is A, all of these is different because this is what? A to the second. This is just A, and this is A to the third. All of these is 3 different variables, so I cannot add them. Okay, I cannot add them. And we just did an activity looking at what like terms are. A squared is not the same thing as A, which is not the same thing as A to the third power. So let's try this one. 2A squared plus 3A squared. Question, don't get frustrated. You just got to focus. Can I add these 2 terms? Yes or no? Everybody needs to answer. Very good. Because look at the variable. Remember, you got to pay attention to the variable and the power. The powers must be the same. So A square, so I can add. So what would be my answer, everybody? Let's go. What would be the answer? Where that B come from, T? Where you get that B from? Okay, what about everybody else? Okay. Very good. So the answer is simply 5A squared. Very good. So we're going to look at some examples now where we have more than one variable. So look at this example. I'm going to rewrite it. 3P plus 2Q plus 2P. Are there any like terms here? Yes or no? Yes. Here we have a P, 3P, and we got 2P. So what I am going to do is rewrite them and group my like terms so I can add them together. So everything that I can add together, I'm going to group it. Remembering that what comes in front is 2P, a plus sign. So the plus sign has to go with the 2P. So I'm going to write plus 2P. And then we know the Q. 2Q is the one odd man out. So we just write plus 2Q. And what came in front of the 2Q? Let me just use a different color. Let me use a different color. Let me use green. So this is going to go with the 2Q. So I know 3P plus 2P is 5P. And I can't do nothing with this Q because it's not a like term. So I write it back. So that's the answer. Everybody got that? That's one person saying yes, 2 persons saying yes. Okay, good. Let's look at number 4. Now, number 4, we had 6m minus 3n plus 2m minus 2m. Now, once you see a negative sign, guys, or subtraction, the integer rules must come to play. So step 1, you realize what we got. We got different variables. We got m's and we got n. Let's group all of our m's together first. So I would have a 6m, a positive 6m, and I'm going to add 2. So I'm going to write that in yellow. 6m, that's your first step. You get marks for this. Rewriting it, grouping in like terms. So let's use red now for the ends. What come in front of this 3n? A subtraction sign. So you're going with that. What comes in front of this 2n? A subtraction sign. So let's come with that. So I'm going to rewrite minus 3n minus 2n. The truth is, once you identify your like terms, you could treat it like regular numbers. So what do I mean by that? If I got 6 plus 2, so 6m plus 2m is the same thing. What's the answer here, my good people? There we go. We need to be sharp on that keyboard. Whatever you are typing on, let's go. 8m, excellent. T, do you agree? Very good, 8m. And she's correct, because if it was just numbers, we know minus -3 minus 2 is -5. It's the same thing, even though letters are here. -3n minus -2n is -5n. It's the same thing as saying if you owe somebody $3, you borrow $2 more. How much you owe them? You owe them 5. Everybody got that? Yes or no? Let me go. That's one person. 2. Just waiting to hear from. Okay, excellent. Y'all doing awesome. Super proud of you. Now we're going to skip all of this because we just need to make sure we understood the basic laws. When you come to addition and subtraction, the first thing you should think about is like terms. I want everybody to say out loud, and you better say it because I'm going to be able to hear if you could say. Say, if I want to add or subtract algebra terms, what am I looking for? Like terms. So addition and subtraction, like terms. That's what you're supposed to say. Addition and subtraction, like terms. Addition and subtraction, like terms. Stick it in your brain, because when you start to do multiplication and division, it's a whole next ball game. Worse when you have a question that involves both. All right, so there we go. We have the laws of indices. We need the laws of indices, and it's the same thing as saying the laws of powers or the laws of exponents. These laws are necessary for multiplying and dividing. So we know when we adding and subtracting, what should we think? Like terms. When we're multiplying and dividing, what we should be thinking? The laws. Okay, that's the first distinction you must make in your brain. So we're going to go through the laws now, and we need to remember, don't get these confused. Addition and subtraction, the only thing we're looking for is like terms. Multiplication and division, the laws. So let's look at the laws. What do the laws say? All right, so let me just clear off this board. Let me see if I have anything below here that I need. Okay, we just got a few simple examples, so I could clear the board. So let's look at the first law. We're only going to focus today on the first 4, because the truth, we're going to do the first 5. We're going to do the 5. 6 is advanced. We don't really need 6 right now. When we reach that bridge, we will cross it. So this is what you have to remember. The first law of indices says, if you are multiplying 2 variables that are the same, so you realize here, what are we multiplying? We're multiplying a by a. You have to add the powers. So here, the first power was m, the second power is m. That's why they have a, m plus n. So let's look at an example. If I have p to the second power times p to the third power, what will be the answer, guys? We know what we're supposed to do with the powers. Add p 2 plus 3, which is equal to p to the 5th power. How do we know that is true? Look at the proof. P squared means what? P times P. Everybody agree with that? P squared means P times P, right? Times, what does P to the 3rd power means? P to the 3rd power means P times P times P. So let's be real, nothing different between this multiplication and these smaller multiplication. So how many P's you ending up with? That's 1, that's 2, that's 3, that's 4, that's 5. That is why we end up with P to the 5. Everybody see that? That's the reason why law number 1 says when you're multiplying 2 variables that are alike, you add the powers. So everybody answer this question for me. M to the 5th power times M to the 2nd power. What is it? What is the answer? That's one person. That's two. That's three. Never going to do this. This does not, remember the law. It didn't say to times it. The law says to add. So the answer, as you rightfully said, is m to the 7th power. Excellent job. All right, so we could take it to law number 2. Law number 2 is the opposite. And that's how maths is. If you learn it one way, to be honest, you will learn and understand it the opposite way because the opposites are balanced. If when you multiply, right, check this out. Let me zoom in a little bit more. And this is the kind of critical thinking you need to have in math. This is the type of connections you need to make in math. When we were multiplying two variables that had the same letters, we add the powers. So that means division is opposite to multiplication. So if we multiply, we add. That means when we divide, what we're going to do? Subtract. Pretty straightforward. So check it out. M to the 2nd, let's use a bigger power. Instead of the 2nd power, let's use m to the 5th. M to the 5th power divided by m to the 2nd power. Tell me my answer, peoples. What will be my answer? That's 1. Come to everybody else. Let's go. That's 2. Excellent. So it would be m5 minus 2, which would be m to the 3rd power. And how do we get this answer? How do we prove it? Let's take a look. Remember we learned this. M5 means what? M times m, that's 3, that's 4, that's 5. Remember what this means? What does that line mean? That line mean what? What does that line mean? What does this long line mean, guys? When I draw this long line, what operation is that? Divide. Exactly. Oh my God, I don't know why I'm stammering. I'm so tired. But we got this. We got this. All right. So when we learn to do this with fractions, we learn to cancel, right? So if you have something in the numerator and something in the denominator that's common, we learn how to cancel, right? So m into itself goes once, m into itself goes to cancel above and below. So what are we left back with? This is what we got to pay attention to. To the top, how much m's we got left back? That's 1, that's 2, that's 3. So it would be m to the 3rd power over 1. And we know anything over 1 is itself. So everybody see the proof? This is our basic proof. Everybody with me? So we understand that when we're multiplying two variables, we add the powers, and we do the opposite when we divide. So when we divide two variables that are alike, we subtract the powers. All right? Okay. So everybody okay with rule number 2? Hi, Trev, welcome. We're just going back over every single thing from top to bottom. We did addition and subtraction. Now we're doing multiplication and division. I just want to go back quickly just to make sure she's with me. Whenever we're adding and subtracting algebraic terms, you have to look for the like terms. Okay? So for example, I can add an A to an A. So like 1 apple plus another apple is 2 apples. But if I have an A plus a B, I can't add that because it's almost like saying an apple plus a banana will always just give me an apple plus a banana. Okay? So that's the rules. Whenever you're adding and subtracting terms, you just need to make sure that you add and subtract like terms. When it comes to multiplying and division, we're going to be using the laws. And that's what we've been talking about recently. The laws of indices. Let me see if I could move to the next page because my thing kind of frozen. All right, so we're back. We're good to go again. All right, so we did law number 1. We did law number 2. Oh, wow. It just crashed on me. I've been teaching literally all day, so maybe my laptop overheating. So just give me. Hello. Okay, awesome. So let's see if we could get back on track. Bye. Okay, so here's where we were. We were at the laws, right? We were at the laws. Okay, so we just did law number 2. So just to recap quickly, if we have two variables, m to the, let me use a different color, black. If I have m to the 6th power times m to the 3rd power, we know that all we need to do is first identify if the both variables are the same. Once the variables are the same, and here we got m and m, the rule said whenever you're multiplying two variables that are like, you add the powers. So we're gonna end up with m6 plus 3. So our answer is going to be m to the 9th power. And so if we're doing though division, so let's use the same two terms, but instead division, instead of adding, we do the opposite, which is subtraction. So it would be 6 subtract 3. And so your answer would be m to the 3rd power. All right. Okay, so that's the first two laws. Now the second law, the third law, sorry. The third law talks about brackets. Remember, we learned that before, that sometimes brackets mean, oh, do it first. And in other cases, it means to multiply. In this example, it means to multiply. My thing just froze again. Oh, bye. How are you guys feeling? Let's just give, I'm gonna call my laptop Betsy because she's moving like a Betsy. It's just ridiculous. You hungry? Me too. I think I might bust a quick pot after. All right, so let's see. Sleepy? Me too. I wish we could have shared some snacks, like, you know? Betsy not feeling it at all. But to be honest, once we finish this, I just want us to go through everything. We're going to tug it out. I appreciate that. Okay, so there we go. Number 3. Here we realize that we have brackets. And what I want you to pay attention to is whenever, for example, if I gave you 3 and I tell you find 3, 2, this simply just means 3 times 2. For the same thing, if I give you 3 and put A inside the brackets, this just means, and you know, 3 times 2 is 6. This just means 3 times A, and we know 3 times A is equal to 3A. So in this example, what you would realize is that we need to pay attention to the powers. So anytime you have brackets where one power is inside, one power is outside, it simply means to multiply both powers. So this would be AM times N. All right, and let's look at an example as to how this is true. Let's look at how this is true. Let's look at the proof. So just to make sure I write this out, this means AMN, because we know when we multiply two variables, we just join them together. Suppose I gave you A to the 3rd power square. What does this mean? This means every time inside the brackets, we're multiplying it by itself twice. What is inside the brackets? A to the 3rd power, right? So that means this means A to the 3rd power times A to the 3rd power. Everybody see that? And we know using law number 1, what's the answer if we use law number 1? We simply do what? Add the powers. So we end up with 3 plus 3, which gives us A to the 6th power. But look at that. Based on the law though, the law says to just simply multiply these two numbers. So if I have A to the 3rd power square, it just means A to the 3rd power times 2, which is A to the 6th power. Everybody see that? Let me know, please. Feedback is necessary. So I'm going to give you one. Let me know if you understand, first of all. Yes or no? Everybody who's here, I need feedback, because remember, this is for you. This is to make sure you understand, you're filling them gaps, you clarify your misunderstanding, you're feeling stronger, more confident. Okay, good. So if I give you this, what's my answer? There we go. What is my answer? What's my answer, guys? Let's go. What happened to everybody? There we go. P to the fourth power brackets to the third power. So that's one person send me the answer. What about everybody else? What do we do when we get brackets like this? All we need to do is multiply the two numbers. So what's my answer? Where you get 64 from? Lovey, let me know. You have 64. Where you get those numbers from? Trev, what you think the answer is as well? Let's go. Because the more people share the answer, the more I could see. Okay, so here's what we have, guys. It's going to be P 4 times 3, which is equal to P to the 12th power. T, you see how we got that? Let's try another one. A, 5th, and 2 outside. What's my answer? That's 1. Let's go, guys. That's 2. That's 3. T, what's the answer? Excellent. A to the 10th power. Now, the last law is simply just this. It's something you need to memorize. Anything raised to the power of 0 is equal to 1. So, for example, P raised to the power of 0, what is that equal to, guys? One. Remember, I just said that anything raised to the power of 0 is 1. So M raised to the power of 0 is what? 1. 10 raised to the power of 0 is what? 1. 25 raised to the power of 0 is equal to 1. Let me explain to you guys how. Suppose I give you this. If I give you M to the 3rd power divided by M to the 3rd power. Using the law, we know we would do what? Subtract them, right? 3 minus 3 would give me M to the 0, which is going to give me, we know M, anything to the power of 0 is 1. But let's look at Y. M to the 3rd power means M times M times M. Because we're dividing, we put division, the division line, and we're going to put divided by M cube, which is M times M times M. We learned before, whenever we have anything set up like this, we could cancel our common entities. We got M's to the top, M's to the bottom. So let's divide by M. M into itself goes once, M into itself goes once. Can we cancel again? Yes, because we have 2 more. M into itself once, M to itself once. M can go into itself once, M can go into itself once. So what do I end up with? 1 times 1 times 1 is 1 over 1 times 1 is 1. Anything over 1 is itself. So you see the proof? When you subtract or when you divide anything by itself, you realize you're going to always get back 1. Hence, the reason for anything to the power of 0 is just 1. P to the power of 0 is equal to 1. Everybody got it? Let me see what you say here. If you had a whole, let me see, equation with more thing, wouldn't it be like -1? You can't, you have to just follow the rules. We're gonna have some examples where we look at when that rule is applied. So we're gonna look at some examples now and apply all the rules and solidify that same question. We're gonna answer that same question using some examples. Okay. So let's look at our next page. All right. So let's look at these questions here. I'm gonna erase everything. And you realize it gave us the answer. So it's just for us to see if we agree with the answers or not. There's one more law that I forgot to make sure we do. Sorry about that. Let me just get it done now. The last law that we're going to focus on is number 5. Now, we learned about inverse already when we did number theory. And I'm going to tell y'all now, if you need to dedicate one day to do your revision, to keep all the information in your mind fresh. So as you learn more complicated stuff, you don't get confused. Anytime you see anything to the power of -1, it means inverse. All right. And so all this first law says is that there's 2 ways to write the inverse of anything. So if you got P -1, you could represent it as 1 over P. These 2 things mean the same thing. That's all it says. If you have M inverse, it just means 1 over M. And let me explain to you how you get that. So let's look at our example. If I have, guys, M to the 3rd power divided by M to the 4th power, you should see what's going to happen here already. Because it's division, what are we going to do with the powers? We're going to subtract them, right? So check this out. M 3 minus 4. But we know 3 minus 4 is what? 3 minus 4 is -1. So that's how we get the answer like this. But look at it if we do it the long way. M to the 3rd power, how much M's is that? 3, right? M times M times M. We are dividing it by M to the 4th power. That means how much M's to the bottom? 4. 1, 2, 3, 4. So before I continue, does everybody understand how this is the same thing as this? That's the first question. That's one person saying yes. 2, 3. Trev, you with me? You understand how this is the same thing? Okay, awesome. All right. So because we divided, just like what we did in the previous example, we cancel it as much as we can. So I could cancel this and this to get 1. I could cancel this and this to get 1. I could cancel this and this to get 1. Can I cancel again? Yes or no? No, because I have no more M's. You must have an M to the top and the bottom. You must have a common entity to the top and the bottom to cancel. So I don't have any more M's to the top. What do I do have at the top? 1 times 1 times 1 is 1. And then you have 1 times 1 is 1, 1 times 1 is 1, and 1 times M is M. So you see how we end up proving that these 2 things is the same thing? Everybody see that? This is the proof. Okay, so only one person said yes. I hope everybody is with me. So to be honest, this rule is just a memorization. All you need to memorize is that anything to the power, negative power, is just 1 over that thing. So let's do a quick thing. We know that R minus 1 is the same thing as 1 over R. S minus 1, it just means 1 over S, even with numbers as well. So 3 minus 1 just means 1 over 3. 6 minus 1 just means 1 over 6. Okay, everybody have that? All right. And the second part of rule number 5, I'm just going to come over on this side, adds a power to it. So I just want you to realize it's the same thing, but look at it. Instead of -1, you end up with minus M. So I'm going to show you how this works. And then that's it for the laws. And we're going to just go straight into practicing and then expanding brackets as well. So if I have A minus M, They're saying the same thing as saying A minus 1 and put M outside. Another way to write this too is by saying AM minus 1. How do we know this is true? Let's look at the law that we just learned. Because this is the brackets, we got to multiply M times minus 1. Minus 1 times M, or M times minus 1, is just minus M. It's the same thing like saying 3 times minus 1 is minus 3. Even though it's a letter, it's the same rules. So you see how I gone from here to here? I just used the law to separate the minus from the M. That's all I did, using the laws that I learned before. Now we just learned that anything to the minus 1 is 1 over it, right? So let's pretend like this is just one thing. Anything to the minus 1 is simply 1 over that thing. So that is how you would end up with that. But the truth is, I'm going to be honest with y'all, we don't use this often. You just need to remember it just for general purposes in case it comes, but this law isn't used often. So for example, we're just going to do a few more examples. If I have 3 to the minus 2, what does this simply mean? Just 1 over 3 to the power of 2. Let's do a few more. If I have M to the minus 2, what does this mean? You keep the power, you keep the letter, you just put it over 1. That's all. 1 over M squared. Let's do another one. Q to the negative 3. It simply means 1 over Q to the power of 3. Let's do another one. S to the power of negative 5. What does this mean? 1 over to the power of S to the 5th power. Everybody see that? Everybody see that? It's almost like a pattern. So you really just got to remember the pattern. Let's try another one. Let's say B to the power of negative 3. What is it? 1 over B to the 3rd power. Everybody see now? Let me know, please. Let's do another one. C to the negative 4 is the same thing as 1 over C4. Sorry, my pen's sticking. That's it. That's the rules. All right. So let's look at these examples here. Exactly. So what rule is number 1? The first thing we're going to do is look at what law. We're going to identify the law that it used, and then we're going to show the working and see if we get back the same answer. So what is the first one? What law is the first one? And you need to memorize the laws, eh? That's why we're doing this. So one person send me the answer. What is this law using? Law number what? Just to make sure we're clear, let's go back and look at all the laws so you remember the numbers. Let's go back if my computer would allow me. All right. So let's go back to the laws. So I'm going to come across. So I need to make sure everybody with me knowing you're paying attention. So law number 1 says when you multiply 2 variables, you add the powers. Law number 2 says when you divide, you subtract the powers. Law number 3 says when it comes in brackets, you multiply the 2 powers. Law number 4 says anything raised to the power of 0 is 1. Law number 5 is with the inverses. Whether if it's minus 1 is the power or minus a letter is the power, it's just the inverses where you represent it as 1 over it. Everybody got that? So let me know if you're ready to do the activity. So let me know. Ready. Say ready, ready if you're ready. Ready if you're ready. That's one person ready. Anybody else ready? That's 2 persons ready. Come on, guys. Remember, we're here just to make sure you get a bit more stronger because we still got 2 more things to do. All right. So let me start it. So step 1, what law is this? Law number what? So one person answer. Let's go, everybody. We need to run through this as quickly as possible. That's 2 persons. What law is number 1? And to be honest, it's so easy. It's law number 1. It says whenever you're multiplying, what do you do with the powers? You add them. So that's why they got P9. Excellent. Law number 2. Number 2, what law is that? Number 2. Very good. So what do we do with the powers? We should do what? Subtract. So B13 minus 1 is equal to B12. What is number 3? Pretty simple. Is law number 3. So what do we do with the powers? 3 square times 3. We multiply. So that's how we end up with 3 to the 6 power. Because this is a number, you could plug this into your calculators and work it out. So let me see. You get a calculator. You put in, what was it? 3 to the 6 power, 3. Let me clear it. That there's 9, Lord Jesus. Forget that. But practice it with your calculator, okay, guys? My laptop really tired. All right, so let's look at number 4. Let's see if we could answer these here and move right along. So law number 4, give me law number 4. Number 4, what law does it use first? What's the first law that it uses? Number 1, number 2, number 3, or number 4? Even before you look at number 5, which one comes first? Because it's division, you're gonna have to use the law number 2 first, right? So it's law number 2 first. You see that? So what do you do with the powers? You subtract. So it's going to be 5 minus 9, and that's how we're gonna end up with K minus 4. But we just learned at law number 5, another way to write this is simply just writing 1 over K4. So excellent. This is a double 1. What about number 5? Number 5 is a double 1 as well. So we start off with law number 2. So we end up with 9, 4 minus 4, which is equal to 9, 0. And that's law number 4. And so what is the final answer, everybody? We know simply anything raised to the power of 0 is 1. That's it. This one is straightforward. This is simply law number 4. W raised to the power of 0 is equal to 1. Look at this here. They try to fool us. Even though it's the brackets, even if we multiply it, you know, anything times 0 is 0. So this is going to give us 6 to the 0, which is essentially still what? Law number 4, which gives us 1. Now, this is where it gets interesting, my awesome people. You see, these last 3 is where it gets difficult. This is something I want to teach y'all quickly before we look at these examples. If I have, right, 3P, and I put this in, let's say I have 3 here. What you must understand is in this example, you have something new to consider. Before with the laws, did we ever have any coefficients? No. And in this example, we have a coefficient. You treat the coefficient with the regular laws. That means that you just apply 3 and you apply the square to the 3. And then you apply the laws with this one here. So it's just going to be P 3 times 2. So what is 3 to the square? 9. So your answer is going to be 9P. 2 times 3 times 2 is 6. Okay, I feel like I might have to do another example. So let's look again. If I tell you, let me see. Let's look at this example and let's see if we could use this example. So basically what I'm saying is, right, you realize what law is this, guys? That's the first question in number 8. What law is that? Law number what? Is it 1, 2, 3, or 4? Anybody remember? It is law number 3, right? Look at it. Law number 3. What does it say you do with the powers that inside and outside? Look at here. Look at the brackets. Look at the power that's outside the brackets. That's law number 3. Everybody see that? So let's look at number 8. Here, that means we're multiplying all the powers inside by 3. Or you have to look at it. In this example, how many variables we have? We got 2 variables. We got y and b. We always treat the variables separately. Each thing is treated separately. So 3, so you write 3. Anything standing by itself, what does it have a power of? So if I had a, what does a have a power of, guys? 1, right? It's the same thing with numbers. Numbers have a power of 1. And what is the rule? You multiply both powers, right? So I would multiply this by 3. Let's look at the y. We were given y to the 4th power. We have to multiply it by 3. And then we have b. We have b to the 2nd power. What do I multiply it by? 3. So the only thing that you have to remember is because this has a coefficient, a y, and a b, you have to multiply each thing by 3. So that's how they got it. 3 to the 3rd power, y to the what power? What would be the power for the y's? Don't worry, if it's a little confusing, as we do more practice, it's going to become clearer. So just answer the questions that I'm asking. What would be the answer for the powers for the y? What is it going to be? Y to the what? Is it 4? Look at this. Remember we had to multiply? So instead of 4, what is it going to be? 4 times 3, right? Which is 12. Everybody see that? And then b, what would be the power of b? What would be my power for the b? 2 times 3 is what? 6. But the only thing is that we're not done, because the truth is we could calculate 3 to the 3rd power. 3 to the 3rd power means 3 times 3 times 3. 3 times 3 is 9. 9 times 3, 27. So that's how they get 27 y to the 12th power, b to the 6th power. Everybody see, let's try this. Let's try the second one. So let me erase all of this. You see how it gets more advanced now? This is where it gets more advanced. And it really comes better and stronger with more practice. So before we do these 2, I want to try one of my own. Suppose I gave you this, guys. Suppose I gave you 4. Let me use a different column. So try this. 4, a to the 3rd power, b to the 5th power. And I put this in brackets and I put 2 out here. What would be the answer for the coefficient? And you should remember that the coefficient means the number in front of the variables. What would it be? Take a try. Even if you're wrong, I don't care. Please try. What do you think, based on what we just did before, would be the coefficient answer or the number in front? And this is the next thing that is kind of be a little frustrating. Y'all don't say nothing. If you don't understand, just say, Ms. V, I don't know. Or Ms. V, I'm not sure. Or Ms. V, I'm stuck. Saying nothing does nothing to help me to help you. So T sent something, okay, but you forget the question I asked. You just forget about the 4. The 4 is the coefficient. So what is going to happen to the 4? Will it remain 4 or will it become something else? Okay, so she thinks it's going to come something else. What is going to happen to it? What should we do to the 4? Just like how you apply this square to the B and the A, what is going to happen to the 4? Okay, so somebody else thinks it's going to become an 8. Do y'all agree? Do you think it's going to change to an 8? Are we multiplying by 2 or are we squaring? Because this 2 suggest something. So it's going to become 16. Why? Because it's going to be 4 to the second power. A, because A to the third power is what we have here. So it's going to be A to the third power. And then what are we multiplying by A to the third power? So all of this is going to be by 2 times 2. Then we have B to the fifth power, which was inside. B to the fifth power. And what are we going to multiply it by? By 2. So T, you had all of the elements correct. So it's just now to incorporate the coefficient, which is the number in front. 4 times 4 is 16. 3 times 2 is 6. So it's A to the 6th power, B to the 10th power. That's right. So all you needed to do was calculate the 4 square. Very good. Let's try another one before we move on. I need everybody to try this one, please, even if you're not confident. If I give you 3m to the second power, and I put a square outside here. So let me just write this a little better. Everybody try this with me and tell me what you think the answer is going to be. Keep it in mind, you have to pay attention to the coefficient, and then you have to pay attention to the variable. So what do you think the answer is going to be? Okay, so I have one person send me something. What about everybody else? Take a try. That's 2 persons. Try something. What about everybody else? 2 more. Let's go, girls. Let's go. Let's go. Let's go. Okay. Okay. Very good. T, what about you? I'm not even sure. Or Bika send me something. Did you send me something? Who didn't send me something? What about everybody else? The other person that didn't send something. Okay. So same thing that we've been doing. You apply the square to the 3 and you apply the square to the m. So it's m squared times 2 because you already have the 2. So you're going to multiply by the 2. So some of you were close. It was very close. So your final answer is going to be 3 squared. What is 3 squared? 3 times 3, right? So that's going to become 9. And then 2 times 2 is 4. So we're getting closer. And that's all I want. So let's try one more before we move on. Let's try one more. Let's try 4. No, I don't want a 4. I want to do 5. So let's try 5. Five p to the third power square. Let's go. Everybody, let me go, let me go, let me go. Super proud of you guys. That's what we're talking about. So that's one answer. That's 2. That's 3. I'm just waiting for T. Okay, Trev, what you have is correct. You need to now work out the 5 square part. What is 5 squared? And give me an answer again. T, I will jump through the computer for you, eh? Don't let me come to the computer for you. Send my answer, please. So Trev, send back your answer, your final answer, after you work out the 5 square. And T, send me something and stop laughing. So you gave me 5 to the second power, but 5 to the second power has a value. What is the value of 5 to the second power? What does 5 to the second power mean? It means 5 times 5. So what is 5 times 5? So that's not your final answer. That's correct, but that's not the final answer. All right. So just to show you what you guys did. So correct is 5 square p 3 times 2, right? But 5 squares, like what I was saying, right? 5 square means 5 times 5. So it has a value. The value of 5 square is 25. And so your final answer is 25p to the 6th power. All right. All right. So to me, you guys have the understanding. We're going to move forward to answering some questions. All right. Let me see what's going on here. We're not going to look at these more difficult questions. I'm going to give you some questions to look at. Guess what? We actually almost caught up. We only got like 2 more slides to catch up to the last class that we did. Okay. I got you. So everybody, let's take a look at this now. Suppose I give you this. Let's start off slow. So everybody get ready to send your answer. What's the answer of A times B? That's 2 persons just waiting for Trev. What do you think the answer is? We're building up slow. All right. A times B is AB. That's the easy rule. You put them together. Next one. What is A times A? Everybody, let's go. That's 1, 2. Ash, is it just 2? This is law number 1. T, what about you? Okay. Trevor, hope you're with us still. All right. So this is really law number 1. The power of A by itself is just 1. So this would just be A1 plus 1, which is A to the 2nd power. And to be honest, to check it, you just see how much A's you have and put it as your power. That's a little shortcut to it. All right. So let's try this one. Ooh, let's use black because we're a bit aggressive. So good job so far. So we're taking it up a next notch. Suppose I say AB times A. Take a try. Remembering that we're grouping them together. Remember when you multiply, you don't have to think about like terms. So far we have 3 different answers. Trev, what do you think it is? When you make a mistake, you get to understand what not to do again. All right, so let's take a look at it, right? What do we have here? We got A's and B's. We got A's and we got B's. But how many A's do we have? We have 1, 2 A's. This is a power of 1. This is a power of 1. Even though this B here, it doesn't affect the rule. The rule still applies. 1 plus 1. We only end up with 1B, so we leave it. So our answer is A square B. Count the number of A's you have. Everybody see now? Everybody understand? And let me know if you understand, and please, that's very important to not make this mistake again. You got it? All right. So let's try this one now. P square Q to the 3rd power times P 4 Q 2. What's my answer? Let's go make an attempt. So that's 1 person with an answer. That's 2. That's 3. All right, so let's check it out. So if we counting, you could use the counting rule, to be honest, or the rule. You add in 2 plus 4. So that's how much? That's 6. And when you got the Q's now, that's 3 plus 2, that's 5. Excellent. Let's take a division stance now. A6 divided by A2. What's my answer? That's 1. That's 2. That's 3. All right. T, I'm waiting for you. But so long, let's just to keep it moving. It's gonna be A 6 minus 2, which is A4. Excellent. Let's keep it moving. Suppose I had now m to the 10th power, p to the 5th power, divided by m to the 3rd power, p to the 3rd power. What's my answer? That's 1 person. That's 2. Okay then. What about everybody else? All right. Okay, so let's check it out. Because we're dividing, we know that we need to do what? We need to subtract, right? So this is going to be M10 minus 3, P5 minus 3. So T, I hope you see the way you make a little mistake. 10 minus 3 is 7. P5 minus 3 is 2. So rather than it being 8, so you ended up adding the 5 and the 3 rather than subtracting. All right, so everybody, we're going good so far. Excellent job. Excellent job. So let's take it up a next notch now. This is something I'm going to teach you now that we have not done. If I give you 2a times 3a, this is the rule I want you to remember. The rules for the variables is not the rules for the coefficient. The coefficient use the regular multiplication rules. That means all I got to do is say 2 times 3, 6. But the variables use the laws of indices. So that means you add the powers of the variables. So it's going to be 6a squared. Everybody see that? That's the same thing for multiplication and division when you got coefficients. So let's try another one. 3m squared p squared times 2mp. Everybody try that for me, please. This is intentional to see if you understand the basic concept. So look at it, make sure you remember all the elements. That's 1 person. 2, 3, 'All right, so let's take a look at it, right? So I'm really happy to see everybody getting the coefficient right because we just said 3 times 2 is 6, right? Then we have m2, and this one, obviously, because it's m by itself, it has a power of 1, right? So that means it's going to be m2 plus 1. Same thing with the p's. It's going to be p, because this is p by itself has a power of 1. So it's going to be 2 plus 1. So your answer is 6 m to the 3rd power, p to the 3rd power. That's what we're talking about, man. That's what we're talking about. So let's keep it moving. We keep it moving. So let's look at this now. Number 9. 10q to the 3rd power, s to the 5th power, divided by, this is a trick question, eh? I tell you, I know, pay attention. 2 to the q 3rd power, s to the 2nd power. So don't get frustrated if you get stuck here. This is meant to Take it step by step. This is a teaching moment, but try it and tell me where you get. I just want to see what answers y'all get. Is this session recording? I think so. Okay, somebody said they're stuck. That's okay. But send me where you get so far. I'll take care of you. Okay. So, ooh, I see I get a lot of things. Let's look at it together. Okay. I'm proud of you guys for trying or just letting me know you're not sure. So let's take it baby steps, right? We know 10. Let's look at the coefficient. So, we got to divide 10 divided by 2. So our coefficient answer is 5, right? Let's write out our working. So since we're dividing, we're subtracting our powers, right? So it's going to be Q 3 minus 3 S 5 minus 2. So let me ask everybody. Everybody understand this first step here, how we got down? Okay, 2 persons said yes. Okay, because that's 1 mark, eh? Trev, you understand how we got that? T, you said wait. You understand how we got that? I find we're doing a lot in a very short amount of time. So I just want to say, big up yourself, guys. This is a lot. This is about 4 or 5 classes that we're doing in one. So yeah, excellent work. So let me go. Awesome. So let's continue now. What you should know, this is what you're going to end up with. 5 q to the power of 0, s to the power of 3. But let's be real. Do we ever leave anything as q to the 0? No. So what is this going to become? 1, right? So it's going to become 5. We're going to put 1 in the brackets and s to the 3rd power. But anything times 1 is what? Anything times 1 is itself. So 5 times 1 is just 5. And so we write back 5s3. So here's a shortcut though. Anytime you subtract something out of an equation, it's almost like saying it's almost like you're removing it. So all the q's gone. It's like you subtract all the q's out. So you realize you only left back with the s. That's a trick. That's a trick. So I'm going to do one more just to show you the trick. And we're going to use the trick rather than going that long, long way. This is the point of this session, to make sure we understand how, why, but also know the shortcuts. Because ain't nobody got no time for all this. So let's check this again. 8m squared P8 divided by 2m squared P3. What do you think the answer is going to be? Let's look at it. 8 divided by 2 is what? So let's take it step by step together. 8 divided by 2 is what, guys? What's going to be my coefficient answer? 4. Very good. So everybody agree with that? You need to make sure you agree. You need to be a part of the discussion. Do you agree? Okay, somebody send me the full answer. Let's see if that's what we get. Anybody else? Everybody with me so far? Let me know. So we know 8 divided by 2 is 4. That's how we get 4. The truth is, we already learned that the short way of doing this would just give me T. How you get 4 when we divide in? How you get 6 when we divide in? So check it again. So because we're dividing, m squared and m squared going to cancel out itself. So m's gone. So we're going to only end up with P8 minus 3. So our answer is 4 P to the 5th power. How was that? A little better? I'm hungry too, dark. We're going to do now because mentally I push myself really hard today. But look at y'all getting there. All right. Whoever listening to this YouTube video, I'm so sorry about that. Okay. So how are we feeling? We feeling okay? I want to try one more. Excellent. So look at this. Negative 2m squared times negative 3m to the third power. Let's try this one before we move on. Use the same rules as if it was just whole numbers. What do you think the answer is? Okay, so let's look at it. Don't forget, what's the rule of integers? A negative number times a negative number is what? A positive number. So negative 2 times negative 3 is positive 6. And then we add the powers 2 and 3. So that's how we get M5. Don't forget. Everybody see that? Let's try one more. Minus 4p squared times minus 3m squared. So let's go. Try this one for me. All right, so let's take a look at it. Negative 3 times negative 4, sorry, negative 4 times negative 3 is going to give me positive 12. And I ain't got none to change for the p, so I write p squared back. And I ain't got none to change in the m, so I write m squared back. Excellent. Look at my student. Very good, guys. Very, 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 very good. Very, very good. So I hope we understand this concept. So now we're going to move on to our last topic of the day, expanding brackets. To be honest, I'm not going to do the double brackets tonight because it's a lot. What I will do though, I can. You ain't get it? Okay, let me go back. Let me go back. We got to make sure we get it. Thank you for letting me know. What did you get though? What answer did you get? Let's try one more. Let's try another one. No man left behind. No man left behind. So let's go. Let's try this one. Okay. Because just to, you understand the answer though, right? You understand why. Because remember, what's the rule about multiplying variables? You just put them together. And since we have nothing to add to them in terms of the powers, we don't have any more p's, we don't have any more m's, we just put them together. You see now? So let's take a look at this. Let's look at minus 2a squared b times 3a squared b. What's my answer? So we're going to end soon, guys, because I know mentally we did a lot. We did a lot. We did a lot. So try this. Tell me what you get. Remember, we multiplying, eh? So Ash, check it again. The variable part is correct, but your coefficient, multiply your coefficient. A negative times a positive is what? Don't forget your rules. So let's take a look at it. -2 times +3 is just -6. A negative times a positive is a negative. And then y'all clearly understand the variable part. So that's how we get A4 B square. Excellent. One more for the road. TSC again, it's good together now. Okay, so let's look at, suppose I give you this. Let me see who won't catch on. -2 A square B square. And if I put this in brackets, square. What is that? That's one person. Anybody else? Anybody else? Because we're going to end class here today. Because to be honest, this was a lot. Okay, Bika sent me Ash. You're trying, you're working on it? Okay, so I'm going to wait for Ash. All right, so I'm going to just scroll through and let y'all know what the topics that we did that y'all missed. Remember, the recording was posted. So in your own free time, you could probably just skim through the video. You don't even have to look at the whole video. Skim through the video and skim through the part that you missed that we're not going to do tonight. Because next class, all we're going to be doing is practicing some questions. And to be able to practice the questions, you need to know everything that we did up until last class. All right, so let's check it out. So Ash, the only mistake you make is a negative sign, right? Because I'm going to show you why. Remember, it is -2 square, A square times 2, B square times 2. Not this last class. Oh, you're right. You're so right. You're so right. There was no video from last class. The last video that I have was from last week, Wednesday. From the Monday, and no recording for the Wednesday. Thank you for reminding me. Wow. I might do a whole recording and just post it with no class. I might just record a session teaching it and post it. So I think I could do that tomorrow. So let's go. -2 square is just -2 times -2, which is +4. And so we have A to the 4th power, B to the 4th power. All right. So I'm just going to scroll through and show you guys what we did so you can stay above. So if you look at this, we're just going to look at it, okay? So just pay attention and follow me. So here we're looking at the brackets, but we did this before. We did the distributive law before. What does the distributive law say? Whatever outside the bracket, you multiply by what inside the bracket. So if I have 3 and I have A plus B, all this means is 3 times A. Let me use a different color. All this means is 3 times A plus 3 times B. So if I write that out, this is what you should have. I'm going to write 3 times 3 times, just so I have different colors. Because it's important for you to see the colors so you understand. So it's going to be 3 times A plus 3 times B. And we know what 3 times A is. 3 times A is 3A plus we know what 3B, 3 times B is 3B. That's essentially what we did last class with one part of it. And then obviously each question is going to become more challenging as you go down and you multiply each term. So we're going to look into that next class. And then what we did after that was we looked at double brackets. So instead of just saying A, let's say we had C plus D, This is a single bracket expansion, but sometimes you have a double bracket expansion that looks like this. We did that as well. Everybody seeing? Okay, no problem. Bye, Ash. See ya. I hope today helped. I hope today helped a lot. And then the last thing that we did, we did a lot of practice. And then the last thing we did was substitution. And that's something a bit challenging that we're gonna have to look at in the video that I'm gonna probably record tomorrow. So my awesome peoples, was today helpful? Okay, awesome. Awesome. So I might need somebody to remind me tomorrow. Just remind me tomorrow to do the recording of the second half of the class that we didn't do tonight so that you can have it anytime you need it. But I'm really glad that I was able to help and strengthen your understanding. And so I'm going to see you guys on Monday. Don't miss class. Bye.